Okay, so something in the last video you mentioned, I might have called it the wrong thing, but I wanted to make sure you guys knew what the extreme value theorem was. We were talking about continuous functions, for instance, functions that just you never pick up your pencil. And what the theorem says is that if you have a closed interval and the function's continuous, so if the function continuous on a closed interval, then your function will have an absolute max and an absolute min. So in other words, if you're looking at a continuous function, such as the page before this, we'll see if I can swap over here. So give me 1 second while I try to find the other document that we had for the last example. And looks like this, I believe. So for this function here, here's your closed interval. You had it at B and at A. And so what that extreme value theorem really defines says, hey, if you have a closed interval from A to B, that you will have a max, which is going to occur here in this case. We talked about that in the last example where the derivatives is a horizontal tangent line set equal to 0. So the first derivative is equal to 0. And it will also have a minimum. So even though this question wasn't asking, it did have an absolute max at, let me get rid of that here, right? So, but it also had an absolute minimum at this value here. So when it's closed, you can use one of the endpoints to be the max or mins too. It just, so in other words, you always check each endpoint and a high or low spot in the graph and see whatever the extreme values are. So a high Y value will be the max, the lowest will be the minimum. So that's what that's really trying to talk about. Now back on, I'm on page 114 here. That's for a closed interval, but for open intervals or intervals that aren't continuous, let's take a look at this example here. So this one will not have a max value. It looks like it's coming up and up and up, and it's discontinuous here at 1. And because there's an open value there, it can't ever really reach it. That's kind of how I kind of look at it. You can define that with different definitions, but when I'm looking at it, this will have no max value because you just really can't get to the max, but it will have a minimum value because there's a point included down here when x is 2. So this function will have a minimum value at 2. It's kind of weird, right? Same thing here. This function won't have a minimum value because it's not defined as it's approaching, x is approaching 0. The y value is approaching 1, but there's actually no defined smallest value. And for that matter, because there's an asymptote at 2, and this is going up forever, there won't be a max either. So this function has no max and no min. If I scroll down here, give me 1 second. There is also a definition, which I talked about in the last video, about a local max and local min. Now notice it's very general, and they're saying, hey, you can have values that are max or minimum on some open interval. So they don't have to be absolute. It's just, I kind of look at it as the highest point on a hump and the lowest point on a hump. You'll see what I mean. I'm sorry, you'll see what I mean in a second here when I scroll down just a bit further. Sorry, I'm hitting the wrong function here. So this function has a local minimum here and a local maximum here. So here's the max and here's the min. That's what we were talking about earlier. But notice the two terms can be used simultaneously. So this value here for your minimum can be a local, now notice the x value is -2. You can have a local minimum at -2 because you're really only talking about in this vicinity here, right? Maybe between -3 and -1, the y value is locally at a minimum here. So that's what they mean locally, kind of in the near the point of interest, so near -2. But it's also an absolute minimum because it's the absolute bottom of the curve, and this function, like before, shoots up to infinity, so it's not coming back down. So that is, that x value at -2 is a local min and an absolute minimum because it's the absolute. So it can be named both. Or at 1 here, you'll notice that that's just a local max. It's not the absolute max because both ends are going to go up to the higher. Then here at 3, that's going to be a local minimum. So the local minimum at 3 is not an absolute minimum because it's not the absolute lowest y value, but it's a local min. I can't write. At both those values, but this one is the one that is also absolute. So you can have a point of interest. In other words, at x negative 2, that's both absolute and local. At 3, this is just local min. And I should have said minimum over here. And you have a local max at this at this value. I'm sorry. I'm thinking to myself how sloppy this is, and it's all I got to work with. So I totally apologize. If you're ever asked, now notice this is not a closed interval, right? It just goes on forever, the x values in both directions. And in this case, you're not going to have an absolute maximum again because this thing shoots up forever. Okay, let me clear all that out. But you don't have an absolute max because this thing's going up forever. So I hope that helps. Next page, next video.